Hello, Priyanka. Thank you. Welcome. You're muted. And I can't, oh, I can unmute you. No, I can't
Oh,
unmute you.
yeah, sorry.
No problem. Welcome.
Thank you so much.
All right. So today, Priyanka is going to be talking about enterprise search engines with Azure Cognitive Search and unsupervised machine learning. So always fun to get some more of these Azure services in there. They're really interesting. I'm going to pass it off to you. Whenever you're ready, we can share your screen and I'll drop out of here. Not my screen, your screen. All right.
So
Passing it off to you.
I'm already sharing my screen. Right. Right.
No.
Should I stop and start again?
It should be working. I see your screen. I'm
All
seeing.
right. All right. Yeah. Yeah. Hello. I lost you, James.
Yes, I did. I was going to drop out and let you do your talk,
Okay.
if that
Sure.
works for you.
So
If you want
yeah.
me to hang out, I can, but I was going to let you go for it.
Okay. I think maybe this topic bar is too broad. Maybe you can switch it off. Yep. Thank you so much. All right. So I'm starting.
You are live.
Hey guys, very good afternoon from Singapore and welcome to this session. Today we'll be seeing the power of Azure Cognitive Search and unsupervised machine learning in one of the real life business cases which we have faced and have implemented. Before jumping into the topic, brief intro about myself. So I am excited to be the new Microsoft AI MVP and I am innovation lead and big data solution engineer. Okay, and you can always reach me on my Twitter handle, which is at fuzzymind1. That being said, so the agenda would be like we'll be introducing the business case, the solution which we initially developed, the constraints around those solution, our entire end-to-end working architecture, and how we brought in the power of cognitive search, synonym API, along with unsupervised machine learning. So basically, the case which we have today is the data explosion problem as we describe it. So you have huge data available in the form of text documents, in the form of error logs, in the form of call transcripts, earning call transcripts, annual reports, and the potential of that data is untapped. So basically, all the data which is there lying around for 10 years, 12 years, 15 years, all that data has a lot of hidden potential which needs to be unearthed. So you'll be surprised to see that seemingly unimportant documents or discarded data or text documents which have been lying around, just stored in some file system, some VM for years together. If you really have a keen look and you exercise the power of unsupervised machine learning on that data, there will be wonders, there will be really huge potential that could be unearthed and unleashed, right? So this is what the current problem is. So there is data all around us, we don't know what to do with that, and we don't know the potential which that data has for us. All right, so our business case was something like this. What we did was we built a document text search engine with the use of Azure Cognitive Search. So imagine that you have a lot of PDF files, PPTs, Excel files, analyst reports about companies, review reports, call reports, performance reports, all those things. And then what if for from all that data I want to search a particular keyword, let's say semiconductor industry, all oil prices, or Wuhan crisis, those kind of words from all the list of documents available. So for those things, you have inverted index search, where you can actually search data from your documents, your text, PDF files, and stuff like that. So that we did using Azure Cognitive Search, and I'll be demoing it shortly, like how the Azure Cognitive Search works currently for our application. Just a very brief information about it. So our search was pretty efficient. We were able to search, phrase search, fuzzy search. So which means if I'm searching for playing, it will also return me keywords for play, played, playful, those kind of things. And phrase search, meaning if I'm searching for a term electric car, and if that terms are not together but maybe separated by few words in between, few sentences in between, still those kind of searches also work quite well. But what about related term search? For example, if I'm searching for driverless cars, it should also return me robotic cars, self-driving cars. If I'm searching about insurance, then it should also tell me about documents which are talking of claim or reinsurance or premium, those kind of things. Similarly, if I'm talking of lithium, and if that word is not present in my call reports, or the search term is not making any much sense, then it should also prompt me that hey, can also search for dry cell related industries where lithium is a component, or other metals utilities which are related to lithium. And again, we can have recommended term search. For example, if I'm talking about oil prices, then it should prompt me that people who searched for oil price also searched for maybe oil reserves, or if people who searched for Pfizer also access reports for other pharmaceutical companies like MSD, Novartis, and stuff like that. So this thing, very quickly I will show you that what we achieved with our Azure cognitive search. So something which we achieved was, all right. Let us try to search, for example, something related to Tata Motors. All right. So let us do that. So it will give you, see, Tata head bar, Tata Motors, Tata Chemicals, and then if I do that, it will actually search this particular keyword or this particular stuff from our. So you see that even though Tata and house here are separated by a huge amount of corpus in between, it is still highlighting those things. Let us look for something like oil oil price. All right. And okay, and you will see that it is returning me reports with oil price there here. Okay, oil price and electric car and stuff like that. Even if even if it is not price, even it is returning close words like prime. Maybe oil price was not present, it is returning me still prime there. Okay, so fuzzy search, word phrase search, all of them are. Let us try for electric cars, and we go here. Yep, returning me call reports, documents which has this word with this a particular group of words present in them. So it, so far so good, right? I mean, we patted ourselves on the back that we did a good job of it. But then when I search it for electric cars, the new question is, can I search for energy conservation, green cars, or stuff like that, right? Pollution reduction cars, or if I'm talking of electric cars, it should prompt me immediately about Tesla, right? So those kind of things. Then how do we go on achieving it? For that, so we'll jump back to our presentation. So for that, the other constraints which we faced are about 500,000 reports available, distributed across sectors, new call reports, new documents, new documentation getting added daily. And then if we were to absolutely tag each of the documents separately, that this document talks exclusively about maybe finance and what are the finance keywords, this document talks about ESG and what are the keywords and stuff like that. So that is, I mean, humanly impossible. And how to tag newly uploaded call reports, how to establish some kind of semantic relationships, that what are all these things talking of, what is the central theme, what is the key thing it is trying to convey. And our complete solution architecture is something like this thing. So our existing Azure cognitive search works excellently when you have exact words present there. But what about word semantics? In which case we are going to use unsupervised machine learning using topic modeling. Then whatever the topic modeling central themes it gives us, like for example, for the finance sector, maybe our set of reports are talking of insurance premium, debt, sales, equity ratios, those kind of things. So we build a kind of dictionary, a first level dictionary. And this is the example. So our dictionary, let's say we are talking of insurance, it should also identify premium, policy, claim, insurance as synonyms. Okay. Then about the text, itself, like what our document talks of, what the sentiment of the document, is it neutral, is it positive, is it negative, and identifying certain personally identifiable entities from that key phrase, named entities, contextual information. For that we use Azure text analytics services. Okay, and then using the LD and text analytics, we tag the documents. So these documents are talking of a particular organization in Hong Kong, companies in Hong Kong, corresponding to the ESG sector or corresponding to the utilities sector. And in the utilities sector, this is the central theme. So we tag the documents, and then we feed the tags to Azure Synonym API, and we iteratively keep on, refining our taxonomy. So we keep on refining our dictionary as and when we find new words added, or new themes added, stuff like that. Okay, so I'm not going into the nitty gritties of each of these things, because each technology we are using here is a separate topic in itself. So just very briefly, cognitive search, what it is doing is it is building an index. So I mean, the way you access data from your database for columns, words, rows, and so I mean columns, rows, and stuff like that. So same way, cognitive search is, just imagine that, you are indexing your entire documents into the search engine, and then you can actually search the text, I mean, I have shown you earlier. Okay, so here you have full indexing, refresh indexing. You can do AI enrichment also. So I can tell that while indexing the document, I want to add text analysis, sentiment analysis to this thing, identify celebrities, identify images, optical character recognition I want in case of images and stuff like that. So your content we are indexing into the cognitive search, and then you can query that using the cognitive API. Okay, and then get back your results as what we saw here, okay, earlier. Now we proceed to the unsupervised machine learning part. Okay, so Azure Cognitive Search is there. We have indexed our data into our cognitive index, right? Now, as I was saying that, why topic modeling? Topic modeling is an unsupervised machine learning technique which helps us to identify the central theme from some text corpus. Okay, so what it does is it helps in dimensionality reduction. Very simply put, dimensionality reduction amounts to, like, I have 500,000 documents, and going through each of them and identifying what they are telling me, what they are trying to tell me, is absolutely impossible, time consuming, and maybe, not objective. Like from my perspective, some document could be talking of energy, from someone other's perspective it could be talking of energy and something else, stuff like that. So it's not objective as well. With unsupervised machine learning, what we do is we can get a central theme, a central perspective of what my documents are trying to tell me. So let's say I have around, a set of call reports in the finance sector, and they are talking of equity ratios. A few set of documents among them are talking of maybe debts and sales strategies or stuff like that. So identifying the keywords, and then a new document coming in will be tagged to that particular group or sector, so which enables me to identify how documents are related, what set of documents are talking about what themes, what things together. So this is what topic modeling does for me. And why we, insist on topic modeling is because a good topic model, it should group my reports together. So I have reports scattered across so many sectors, categories, and to get a semblance of what they are trying to tell me. So let's say if I build a good topic model, then it should identify like, keywords like health, doctor, patient, hospital, and group them together as one particular segment. Okay, or farms, crop, wheat should be grouped into one particular segment, so that I will not, I mean, whenever a new thing comes in, or whenever I'm trying to search synonyms, I know that these things talk of one particular segment or topic, another set of things talk of another things or topic. Okay, and then that also enables us to organize and label the data, and also make informed decisions, right? So when one of us few the user is trying to search electric cars, then I should have a way to tell the the model, or I should have a way to tell the cognitive search that hey, electric cars also means the same as energy saving cars, or electric cars also amounts to all the companies who are investing in electric cars like Tesla and stuff for that matter. All right, which is what it helps us in doing. It helps us in identifying the hidden uh, information in our documents. Okay, so for example, whenever we are tweeting, right, so any tweet which we put out, or anything on social media which put out, it is composed of some themes like sports, or entertainment, or physics, or any sort of those education. So what when you are doing sentiment analysis, or when your recommendation engines run online to recommend you products or stuff like that, what they are trying to do, they are trying to gauge the central theme of your entire text, or whatever the data out there, right? And it is used in various applications like Stack Overflow, to find questions which are similar. So whenever whenever we are blogging, or whenever we are submitting questions on Stack Overflow, you're always asked to tag your question. So what sort of category it belongs to, whether it's a programming, within programming it's C sharp, within C sharp it is related to ASP.NET or stuff like that, or Python and stuff. So that these tags are then useful for grouping questions together and finding the answers of these questions whenever you are searching, right? These are topic modeling is also used by newspaper applications to boost their recommendation. So recommendation engine, so people who read this also read this kind of. Then product recommendation, so when you are buying online, then people who brought this product also searched for this product and stuff like that. Okay, they are also used to organize emails and much more. So that's a topic modeling is a very fascinating aspect within itself. And within topic modeling, we are using something called as LDA, which is latent dirichlet allocation. So latent dirichlet allocation is just like unsupervised. So which means, let's say I start off with absolute no knowledge of my data. Okay, so this is dirichlet allocation. What it will do, it will find out the latent patterns in my data. So latent um, themes or latent information in my data, and then it will allocate it. So once we have the distribution, it will allocate the topics to the documents. So within the finance sector, as I said, there could be one particular topic which is talking of insurance, reinsurance, another topic which would be talking of sales and distribution, those kind of things. All right, so we will see how we implemented the LDA and what all things it unearthed in its when we implemented LDA. Okay, so let's quickly see. So let's see that within the real estate segment, this is how the HTML representation of the Python code and the unsupervised machine learning which we did. So let's look into one particular, let's say, energy sector. All right, so all these things which you see, so within the energy sector, what it did was it identified themes. So these 1, 2, 3, 4, 5, 6 you are seeing are themes. They are nothing but themes. And within these themes, what are the keywords which are available? And you see a good topic model should have should have a good distribution, a less overlap. So if you look at this particular, it has a lot of overlap. So this is the topic. The LDA did not do a good job of segregating into separate topics. But if you look at the energy, here we have a good distribution. So it identified around 10 themes within the energy sector itself, and then it tells us what are all these things talking of. So let us look at our topic one, right? So topic one talks about net product EBITDA. So these are ratios, right? Recommendation. Then it talks of low yield and stuff like that. Okay, let us see what our topic 4 talks of. Topic 4 topic for talks of volume, high, low, decline. So it talks of those things like the yield is expected, sale, decline in the sale and stuff like that. Let's see what 3 talks of. 3 talks of management, company, government. Okay, and those kind of things. With there could be some words like product or management or some things which could be common across different sectors. And then that is where we have to iterately refine our model. So maybe I should say, okay, oh, just ignore the word product or government or strategy, because it is common and it is not going to tell us anything specific about what the reports are talking of, what the documents are talking of. Let us look at 7. Now you see immediately the topic 7 within energy only. Topic 3 was talking of government yield and those kind of things. Topic 7 now it is talking of oil, gas, refineries. So again, related things: oil refinery, gas refinery, exploration, natural vessels, so oil vessels. Okay, let us look at topic 9. Topic 9 is now within the energy sector. It is talking of coal volumes and the I mean the tons of coals producer, plant. So plant meaning the coal plants and stuff like that. So now you see, like, next time a document talking of these kind of minerals and stuff, I know that they will have to belong to topic 9. So maybe I can make a dictionary where coal plants or coal facilities and mineral iron ore, these could be synonyms together. And I mean similar on the similar lines, let us look at another sectors, which is utility. Okay, maybe energy and utility is a bit same. Let us look at industrial or materials. All right, so in material sector you can see that topic 8 is talking of project investment, petrochemicals, those kind of things. Topic 9 is talking of potash, wood, iron ore. So now you see all these things: phosphate, fuel, iron ore, wood, potash. So I don't even know the terms which are in my documents, and then it has very beautifully unearthed information about what my documents are trying to tell me and group them together, and it also giving me the frequency of terms which occurs. All right, so same way. So now here you see topic 10 is talking of all chemicals, lithium manufacture, plastic. Okay, salar brine, potassium chloride. So if as a human going through all these reports and trying to see what terms occur and how the reports are related, you just get the sense what the power of machine learning and what we can do. And this is just the tip of the iceberg. Like, this is just the first level of taxonomy. We could refine it over and over so much time to get a much better representation. Moving on, so this is what LDA did for us. So we got the first level of I mean, we got the central theme of our topic. So this was the demo which I showed you. Now next thing was to get hold of text analytics cognitive services. Basically what they are going to do is they are going to extract key phrases, which I'll directly show you in I mean as a demo. All right, so you see that let us take one call report which we have. So this is how analysts write a call report. They write about the company description, and they talk about some things like what are the prospects, why we should invest and stuff. Okay, so let us enter something. Okay, um let us because this is a demo site, it is not going to take in the entire corpus. So whatever corpus is accepted, when you click on next step, just look at how beautifully it gives me information about what are the named entities, what is my document sentiment. So the sentiment is neutral because, as you see, it's a very descriptive thing that so and so is a company and it is into manufacturing and stuff like that. So it's not talking of any I mean, untoward happening or very positive stuff. So it's a neutral sentiment. And now you see that it has identified entities. For example, this is something like name of the company, then components, and you see that it has extracted some key phrases like focus on consumer products, smartphone, TV, game console, server, networking. So it has identified key phrases, right? Then it has linked those entities. Okay, and then if you see in the next step, it will give you more information about those. Okay, so Hon High is an organization. Okay, then if you look at gaming console, it has I mean it has identified it as a product. Okay, then Southeast Asia, it has identified as a region. smartphone. Then Terry Geo is a person, it's an individual. Okay, so these things if you see, I mean, once you extract the key words and key phrases, and then you identify known people, okay, known people, known organization, then it is even easier for us to tag documents. So I can tag all the industries in Hong Kong area together, or within Hong Kong, people, I mean, belonging to one particular strategy, say China strategy together. Okay, so it has identified China, India as countries, right? So you just see that, all these things which I'm getting, unique business model, global logistics, or consumer products. So all these information also is very important for me to tag my documents. Okay, so moving on. So this is how, Azure Cognitive Services is going to help us. Again, as I said, I have just briefly touched the topic. It has a lot of potential in itself. Sentiment analysis, language detection, NER, named entity recognition is what we said, that, identifying people, companies, organizations. Okay, and then these are the features of text analytics. You can group and identify, process structured data, deployment. And the Azure, finally, when we do this, so we have the documents, we have the topics, we have the key phrases. Now we are going to use the cognitive synonym search API to say that, okay, so health and hospital and patient and doctors together form a set of synonyms. So someone who's searching for doctor, please also search for reports talking of patient or vaccine or stuff like that. Okay, so, for example, when I'm searching for car, automobile, vehicle, four wheeler are the synonyms. And cognitive synonym API is not, unfortunately, available as an SDK, or, as a UI. So you have to use Postman for that. So it is, I mean, you can use it during the, I mean, using the REST API. Okay, so you can post or get and post. It's a REST API. It is not available as a feature on the Azure configuration. So this is how you are going to do it. You're going to feed the fields. Okay, you're going to make a synonym map, and you're going to pass the synonyms. Okay, all right. I just want to finish off with a nice demo of how the Azure API works. Okay, so let's say I'm typing, synonym API works. So let's say I'm typing in the word lithium. Okay, so again, it works as a type ahead suggestion. So I type lith, it will give me a list of words which are there in my index. Okay, and then if you see lithium, when I'm typing, it is also giving me suggestions about lithium ion. So which means lithium ion, it's the ionic batteries, right? So you have the lithium. Okay, sorry, I have to Google. I have to select Google, and then when I'm saying lithium ion, it should give me. Sorry, I type lithium. It should give me, show nearest. See, it shows me lithium ion batteries, lithium battery, lithium battery. So as soon as I type lithium, all these are synonyms given to my cognitive search API to tell me that, hey, these things, are related together. Let us type energy, right? Now see, it is giving me energy equivalency conversion, energy consultancy, energy regulator. Now, as I was saying that, our taxonomy which we fed is only the first level, so maybe it's not as refined, but still it is giving us a good result. Now let us say oil. It is going to give me oil spill, oil prices immediately, like, so I know that oil sands and I all these words are related. Okay, it can also give me similarity of two words, like how similar two words are, but that is something which is currently not uh, important in our context. Okay, so I mean, word analogy also. For example, let's say if oil is to the Gulf, then XYZ is to what? Okay, or if let's say Joe Biden is to US, then XYZ is to, or India is to what? So those kind of word analogy also it can give us. That is, advanced machine learning concepts, natural language processing concept. But for our API case, as you can see that as soon as you type something, it is going to give you like king. It gave me kingfisher, it gave me kingdom, and those kind of things. And if I just type king and show nearest, it is going to give me the name of all the kings, like Jackson. And synonyms of king is prince, again queen also, Martin Luther King, Adams, Brown, all these sort of things. Let us try for energy. Let us see the nearest word. See, it is giving me clean energy, gas, renewables, natural gas, which is precisely what I want, right? I mean, energy domain of someone searching for energy should also be able to search for all these kind of things, petroleum and stuff like that. So this is the power of having machine learning give us the themes and then feeding it to the Azure synonym API to help us reach our goal. And I end my discussion here about how we built an entire search engine. So I'll be happy to take any questions.
Awesome. Thank you very much, Priyanka. That was amazing. So, starting out, there was one question that I saw come in. There was one on how do I bring in a PDF file that is not text selectable in cognitive services?
That is not.
Anything like Yes, that does not have text. So it's probably one that has like an image. So
Yeah,
probably
it is
similar
okay
to.
still. Yeah, you can still, you can, because whenever you're feeding file into cognitive search engine, Elasticsearch or Azure Cognitive Search, it is converted into a base 64 format, so which is okay. Even you have images there, okay, and images you want to be able to index or do that, it is perfectly fine. So let's say your images have some characters in them written, characters written in the images, handwritten text also. It's okay, you can add AI enrichment there and tell it that I want to have optical character recognition, handwriting recognition, extract handwritten words from that image. Still possible, no problem, can do that. uh,
Exciting. So thank you very much. We only have time for the one question due to the next speakers are ready. But thank you very much, Priyanka. That was an awesome talk. AI is exciting and really fun. So thank you very much for joining us.
Thank you so much.